Okay, today we're going to use quadratic functions to model real-world situations. So guess what that means? Word problems. Okay, so this is 8.4, modeling with quadratic functions. So a company offers rectangular pool sizes with dimensions as shown. Each pool includes a deck around it. If Carolina wants an 18-foot wide pool with a deck, how many square feet will she need to have available in her yard? Well, before we worry about that 15-foot wide, let's write a quadratic function to represent the area of the pool and the deck. Well, first thing you should probably be asking yourself, how do I find the area of a rectangle? Area is equal to length times width. Okay, now please notice if I'm looking at the pool, the width is x feet, the length is 2x feet, okay? But we also have this deck tacked on. Okay, notice the deck is 4 feet wide. Okay, so if I'm counting the pool and the deck, I need to add 4 feet here and 4 feet here. So really, my length is going to be 2x plus 8. Same thing has to happen to my width. Okay, I had to add 4 feet on here and 4 feet on here. Okay, so really the width is x plus 8. So now we can just plug those in. Area equals, again, the length was 2x plus 8, and the width was x plus 8. Okay, so I don't like how this looks. So let's make it into standard form. So let's FOIL. So first times first, 2x squared. Outsides, I have 16x. Insides, 8x. Last times last, 64. Okay, combine terms. 2x squared plus 16 plus 8 is 24 plus 64. Okay, so that's how we can model the area. Okay, so part B now says find the area of the pool and the deck. Okay, so we just had the formula as A equals 2x squared plus 24x plus 64. Let me just check real quick, make sure that was right. Yes. Okay, now I care about the 15-foot wide. Well, x was how wide our pool was. So I'm just going to plug in 15 for x. So 2, but instead of writing 15x, I'm going to write 15. Again, plug in 15 everywhere I see an x. Okay, so I hope you have your calculators handy. Okay, exponents, so I get 2 times 2, 25. 24 times 15 is equal to 360. Okay, 2 times 225 is 450. 360 plus 64. Okay, so 450 plus 360 plus 64 gives me a grand total of 874. So my area is 874 square feet. Okay, so suppose the length of the pool is 3 times the width. Okay, instead of making this 2x, it's now 3x. So how does that change our function? Go ahead and try. Pause the video. It's the same process. The deck's still 4 feet, so I need to add 4 onto each end. So this becomes 3x plus 8. I need to add 4 onto both parts here as well. So that becomes x plus 8. And we're just going to FOIL again. So the area is equal to 3x plus 8 times x plus 8. Okay, so FOIL. 3x squared is 24x plus 8x plus 64. Okay, combine my like terms. 3x squared plus 32x plus 64. Okay, so notice just by changing one number, A and B change. Okay, next thing we're going to look at is called the vertical motion model. Okay, this is how you can find the path of a soccer ball if you kick it, if you throw a softball, you're shooting a basketball, throwing a football, whatever. Okay, or launching a rocket. Okay, this is the formula used for vertical motion. So h of t equals negative 16t squared plus v naught t plus h naught. Okay, h, just plain old h, is the height, okay, in feet. T is time in seconds, okay, after it's launched in the air, because we always start at time 0. Doesn't make sense to have negative time. V naught, okay, that v sub 0, Okay, we call it V naught. Naught, N-A-U-G-H-T, is an old-fashioned term for zero. Okay, V naught is the object's initial vertical velocity, and H naught is its initial height. Okay, so when I have V naught and H naught, it's right when we're starting. So let's figure out how to use this formula. Okay, so remember H of t equals negative 16t squared plus V naught t plus H naught. So a diver jumps off a high platform at an initial velocity of 16 feet per second. What quadratic function represents the height h of the diver after t seconds of the dive? Well, it tells us the initial vertical velocity is 16. So that's what v naught is. So h of t equals negative 16t squared plus 16t plus h naught's the initial height. Well, how high is the diver? Well, it tells us right here. His initial height is 30 feet. So there is your quadratic. Right, so the diver jumps off. Okay, we're still using that same formula. So h of t is equal to negative 16t squared plus 16t plus 30. Okay, we want to know how many feet above the platform will the diver be at the highest point. Well, here's the highest point. What's another word for that highest point? That's the maximum. So we need to find the vertex. So how do I find the vertex in standard form? Well, I use my axis of symmetry, negative b over 2a. Okay, so remember a, b, and c. So negative b is 16, so negative b would be a negative 16 divided by 2 times a. Well, a is negative 16. This is negative 16 over negative 32, which reduces to 1/2. Okay, if you want to make it 0.5, that's fine as well. Okay, so to find the rest of the vertex, I got to take this 0.5 and plug it in for x. Okay, so I know the vertex is 0.5 comma something, so let's plug it in. So I have negative 16 times 0.5 squared plus 16 times 0.5 plus 30. Again, calculator work, very handy here. Negative 16 times 0.25. 16 times 0.5 is 8. Okay, and negative 16 times 0.25 is a negative 4, plus 8 plus 30. Negative 4 plus 8 is 4, plus 30 gives me a 34. So how high does this guy end up? 34 feet is his maximum height. Okay, because this is all I care about. Oops, I went backwards. Okay, so your turn. Pause the video and try this problem, please. So we're finding the diver's maximum height above the water if he dives from a 20-foot platform with an initial velocity of 8 feet per second. Well, remember, h of t is equal to negative 16t squared plus v naught t plus h naught. Okay, so let's plug and chug. So h of t is equal to negative 16t squared plus, initial velocity is 8, so 8t plus the initial height was 20. Okay, maximum height, again, I'm looking for the vertex. So axis of symmetry, x equals negative b over 2a. 8 is b, so negative 8 over 2 times negative 16. Negative 8 over negative 32. This gives me 1/4, or 0.25 if you want to write it that way. Okay, so to find the height, I plug it in. So here we go. Negative 16 times 0.25 squared plus 8 times 0.25 plus 20. Well, 0.25 squared is 0.0625, so I have negative 16 times 0.0625 plus 8 times 0.25 is equal to 2 plus 20. Okay, if I go ahead and multiply negative 16 times 0.0625, I get a negative 1 plus a 2 plus a 20. Negative 1 plus 2 is positive 1 plus 20 is 21. So the maximum height is 21 feet. And he reaches that at a time of 0.25 seconds. And that's what the x represents. And those are your basic word problems with standard form. Okay, being able to find area and being able to do vertical motion. Homework tonight, you're on page 341. You're doing problems 11, 14, 16 through 19, 24, and 27. Have a nice day.